Okay, welcome everyone to this week's Compiler Architecture meeting. So for this week, we have one topic on the agenda, maybe not a particularly large one. So it's actually issue 3778, which is the introduction of an instruction delegation hierarchy that can be used for project specialization of the instruction class. So I'm just going to be going through the proposal. Happy to hear any thoughts or alternatives to the design. So basically, the idea here is that when you look at the instruction hierarchy, it's actually formed from a base class that is an extensible class in OMR parlance, and then from that base class, the TR instruction concrete class that's created. The actual instruction hierarchy itself that's built beneath that of the different instruction kinds on the different architectures is a dynamically polymorphic hierarchy that uses, virtual instruction, virtual functions, and things like that for doing its extension. At the moment, the only place where you can really do project-specific stuff is up in the base class, and the reason for that is because it's the only one that's sort of architected that way, where you can actually provide either architecture or project-specific overrides in the base class. But the problem is that in some cases there are some instances where some of the instruction kinds themselves may require project specialization, and there isn't really a convenient way of doing that outside of using if-defs. And I'm not saying that if-defs are the convenient way of doing it either, because there are certainly some complications and some ugliness associated with that. So having said that, that is a valid-ish way of doing it, is by introducing if-defs to understand which functions can be overridden in projects and that kind of thing. You can provide alternate implementations for, but I didn't really want to consider that because it is ugly, especially if you have multiple functions that might want to get overridden that way, and also because we already have a mechanism that we've architected, namely extensible classes, that we should be using for doing this kind of thing. So when we first did extensible classes many years ago, we kind of knew that this would be a problem with the instruction hierarchy, and at that time, I guess we kind of kicked the can down the road and thought that we wouldn't actually have to look. One thing that we could do is to go to each of these individual instruction kinds and make them all extensible as necessary. And because at that time there wasn't really any need to add any project specialization, we didn't actually do that. So that work hasn't been done, but that is certainly an approach that we can do here, is to actually go around to all those instruction kinds and make them individually extensible classes. Following in the design here, I actually have a little example here of what that code would look like. I don't have these figures numbered. It's the second ASCII diagram there. But basically, you could provide an OMR base class in the OMR project. You could provide your own override of that, and then you can produce a concrete class from that. That's a perfectly valid thing to do. The main drawback of this approach, though, is that it really introduces a lot of files to the code base, because you would need separate files for each class that you make extensible this way, and because the instruction hierarchy may have multiple, like many instruction kinds, this can actually blow up quite quickly. So I didn't want to entertain that thought for too long. I'm sure there might be some creative ways of combining files together, but that may lead to other problems in the future, and I was hoping to find something a bit cleaner to do. So So what I've decided to do instead was to actually introduce a hierarchy that lives in parallel to the existing instruction hierarchy, and I've called it the InstructionDelegate hierarchy. And the whole purpose of that InstructionDelegate hierarchy is to provide basically anchor points in each project. It could actually be anchor points in each architecture as well, but that's not really how the instruction hierarchy is put together. But basically provide anchor points in each project where you can put project specialized code. And the way that you would do this is that you could introduce a function at each project level where the first parameter or some parameter of that function would be a pointer to the actual instruction kind that you're trying to provide that functionality for. So it says here, the purpose of this hierarchy is to provide project-specific static delegate functions to instruction kind classes. Static is key because we don't want to create an instance of this hierarchy. These are functions that can be called from anywhere, as long as you pass it an instance of one of those instruction kinds. And the purpose of passing that instance is to really identify which version of that function to actually call. Because you could have the same function that is potentially used in different instruction kinds, yes. And the way that you would distinguish that is with the first parameter, which is a pointer to the instruction kind. So this hierarchy is an extensible class hierarchy. It follows the same construction rules. There are some subtle differences, though. One is the fact that for instructions in particular, there aren't really any architectural specific classes because you're only creating this for a particular architecture. So you wouldn't, in a normal extensible class hierarchy, you kind of weave in and out between architecture specialization and sort of the common code of that particular project. You wouldn't do that. You would basically just go from architecture specialization in one project, you extend the architecture specialized class in the previous project in OMR. And only static functions are allowed in this hierarchy. The idea here is to greatly reduce the number of files required. You basically would require a couple of files in each project for all the instructions that you want to handle this way. One little wrinkle is the way that you can access. So right now with the instruction hierarchy, you can basically poke and grab any piece of private data that you want, provided you already have access to it, like it's protected or something. However, with a parallel hierarchy, you may not have access to that data unless there's a getter for it, or you may have to use some creative use of friending or something like that in order to get at that data. Not necessarily ideal, either of those situations, but I think that for the application that we have in mind here, I think that it's adequate for that. And then just the last little diagram here just shows some very simple sample code of what this would actually look like. So if you actually had a virtual function in the mem instruction class that wanted to do, let's say this function prem that wants to call something that's project specific, it would actually reach into the instruction delegate hierarchy and pass in a pointer to itself, and that would basically find the right version that you want to call. And you can see there that we've got an OMR instruction delegate for that function, but we also have a project-specific delegate for that function. So in this case, it would end up calling the my project version of that function. The other reason for passing in that instruction pointer is so that you can actually call some of the getters or other virtual functions on that instruction. So you can see there that's what it's doing. One potential drawback of this approach as well is that this class, this instruction delegate class, has the danger of becoming a kitchen sink of just a collection of static functions that are unrelated to each other, but are just there to serve certain instructions. In some sense, that's pretty much why this hierarchy exists, is to provide that kind of functionality while sacrificing, and reducing the number of files required. But in practice, though, I think, especially for the instruction hierarchy, I don't think that we're going to see that explosion in the number of project specialized functions. There will be some, but there won't be an overwhelming number that would make this, look like too much like a kitchen sink. So the code itself is actually fairly simple to write. I didn't actually provide a pull request for that. I will actually if this is something we want to do. But I did want to introduce the idea. This is certainly applicable. This kind of a pattern is certainly applicable to other hierarchies as well. It doesn't just have to apply to the instruction hierarchy. It could apply to things where it's difficult to add, where we have a dynamically polymorphic hierarchy, but it's difficult to add project specializations there. I have the symbol hierarchy is one that comes to mind as well, where this kind of thing could be useful there too. But let's start with the instruction hierarchy and see how that goes. So maybe turn it over to see if there's any comments or questions about how this is expected to work or that kind of thing.
How is this better than a virtual function?
So the problem with the virtual, the problem with the virtual function is that you're going to need to provide, you're going to need some place to provide the project specialized implementation of that virtual function. So and at the moment, there isn't really a place to hang that. So this is really just building on top of the mechanism that we already have in place, namely the extensible class mechanism to provide that kind of an override mechanism. Because in some cases, you're not actually overriding, you're actually replacing that version, because the way that because you need to provide your own version of that function. Like you're not, like for example, the x86 mem instruction, you're not actually subclassing that to provide your virtual function. You're actually replacing a function, an alternate implementation of that virtual function with your own. So you need that. You need some kind of a mechanism for saying, don't use that implementation, use this implementation. There is an example of that in PowerPC actually, where they override one of the call instruction classes. OMR provides its own version with ifdefs. It's all guarded like that, and then they have a version that's in OpenJ9 where they provide their own specialization for that. It makes that a lot cleaner. And that kind of code would get cleaned up by this. Any other thoughts or questions? I think the next thing, aren't any large objections to this, is to actually produce a pull request that shows this in action.
Is the end goal just to eliminate the J9 project specifics of?
No, the goal here was to provide project specialized behavior within certain instruction classes for things like GC maps and on some of the encoding functions was to remove some of the project specific. Yeah, I mean, yes, there is some project specific stuff in there, but it's not really guarded with if dev project specific.
Reasonable.
Any other comments? No? All right, okay, well, at some point in the future, probably see a pull request that that shows it in action, so and can sort of evaluate how it looks. Okay. So that's all I had today in terms of a formal agenda. Anything else anybody wants to bring up? Talk about? Okay. All right. Well, I guess we'll adjourn then. Thank you.